Welcome to our presentation, Elementary Science 101 for the primary classroom. During this presentation, you will learn more about the elementary science classroom, why teaching science is important, what students are learning, how they are learning, what you could see in a science classroom, what students experience, how science is taught at the elementary level, resources used to help instruct students, and how you, as a caregiver, can support science at home. Everything we do in our district aligns to our district vision and mission. Our district vision is preparing students for life. Our district mission is to provide an education and the supports which enable each student to excel as a successful and responsible citizen. If you're watching at home, please take out a piece of paper. For those of you who are working with a group, you now have a piece of paper. We are going to think, how can you change the piece of paper we just handed to you? Take a few minutes to explore changing the shape of your piece of paper. When you are finished, you are then going to draw a picture of how you change the shape of paper in your own notebook. Don't forget, label your drawing. This is a quick and easy activity that connects to a science standard for kindergarten, which focuses on changes to materials like paper that include cutting, rolling, tearing, crumpling, and smashing. This could be an example of a hands-on activity that you can do at home with your child that connects to something they are learning in school. We will be sharing other quick and easy hands-on activities that you can do at home later in this training. Please take a moment to read the quote on the screen. This serves as a compelling reason why we teach science in the elementary classroom. Science is a part of our daily lives, and as we head into the future, it will be more vital in all aspects of what we do. For that reason, we must develop scientific literacy in our students so they are prepared for the world in which they live. The materials that you will need for this slide are the grade K2 NGSSS foldable, which is in your packet, markers, crayons, and/or colored pencils. The learning that takes place in the science classroom is aligned to the next generation Sunshine State Standards that were adopted in 2008 by the Florida legislature. Each grade level has their own specific standards that each student should master by the end of each grade level. The standards fall into 4 bodies of knowledge: nature of science, physical science, earth science, and life science. Each body of knowledge is further broken down into big ideas which have standards connected to them. Even though each grade level has their own specific standards, each year builds upon and/or is connected to the previous year's learning. We are going to provide you with a few moments to look over your child or children's specific grade level standards so that you can become a bit more familiar with what they are learning this year. Now that you've been able to look over the next generation Sunshine State Standards for your child's grade level, please take out your science notebook. On the next page in your notebook, please draw a sun at the top of the page. This is to represent the NGSSS standards. And please write one thing that you were surprised to see your child will be learning about this year. For this slide, you will need your science notebook. In the science classroom, discussion is a key component to learning science. We will model a strategy called PB&J. This will facilitate discussion. This strategy is a way to get students to turn and talk to their neighbors about their thoughts and ideas in science. The P stands for pivot, the action of turning to their neighbor. The B stands for blab, referring to talking to their neighbor. And the J stands for jot, which refers to writing what you have discussed and heard in your science notebook. At this time, I would like for everyone to PB and J about what you wrote in your notebook regarding the next generation Sunshine State Standards and what surprised them. Please take between 2 and 3 minutes to do that. As you can see, conversation in science is critical for students to share their learning, questions they have, and time to make sense of the science concepts they are learning. Conversation also fosters collaboration and emulates how real scientists go about their work. This structure is just one example of how teachers engage students in scientific talk. Teachers in Hillsborough County follow a specific model to instruct students in science. This model is called the 5 E's of Scientific Inquiry Model. The 5 E's are engage, explore, explain, elaborate/extend, and evaluate. The engage portion of the lesson is where the teacher provides the students with a quick model of a hands-on investigation, demonstration of a scientific phenomenon, an engaging video, a scientific scenario, etc. Something that is going to get the students interested in the science that they will be learning about and curious where they begin to ask questions. We did a mini engage at the beginning of this presentation with physically changing the paper in our hands-on activity. The explore portion of the instructional model is where students are involved in a hands-on investigation or experiment to begin interacting with the scientific concept or topic they are learning about. Here they are using materials to explore a concept that is new to them or adding new learning to something they've explored before. The explain part of the model involves students making sense of the science. They are making connections between the hands-on investigation and the vocabulary, engaging with complex text that supports the science, viewing scientific-based videos, recording their thoughts and new learnings. This helps them connect to the science they are learning. If there is time to elaborate on the science, students are digging deeper within the topic they are learning and being presented with different hands-on experiences, alternative pieces of text, among other things, to extend their learning. Throughout the entire 5 E's process, the students are being evaluated by their teacher through daily observations, exit ticket questions to monitor learning, understanding, possible misconceptions, scenario-based probes, assessment, and quizzes. As one can see, the science classroom is very busy with many different strategies going on at one time to make sure students learn the specific standards that are being addressed. At this time, please turn to the next page in your science notebook and draw a graphic to represent the 5 E's of the inquiry model. This is to help you remember the model and its components. For this slide, you will need the half-sheet week at a glance chart that is in your packet. When looking at the week in science, globally, we can look at it in terms of 2 parts, Mondays and Tuesdays through Fridays. Inquiry Mondays are reserved for focus on the nature of science standards, the process skills, and the STEM design challenges. So on Inquiry Monday, students are engaged in lessons that focus on developing these skills apart from the content standards. The majority of the first 2 9 weeks are dedicated to the process skills on Mondays. After that, students are involved in STEM design challenges that span 4 weeks at a time. These STEM design challenges were created to provide students with the opportunity to experience how engineers create and design solutions to solve real-world problems. Tuesdays through Fridays are dedicated to the content standards that fall under the physical, earth, and life bodies of knowledge and connect with the nature of science standards throughout instruction. The students are exploring the content standards through the 5 E's instructional model that we discussed on the previous slide. The typical week's activities in science varies from week to week and from classroom to classroom. However, the basic components and time devoted to hands-on, student talk, students working independently, and teacher talk should follow this model. Approximately 60% of the student's time in a week in science should be spent on hands-on instruction, where students are actively engaged with using science tools and manipulatives. Discussion in science should be approximately between 20 to 25% of their weekly time in science. Approximately 10 to 15% should be dedicated to teacher talk and 10 to 15% on independent practice. Remember, this is for time spent during a week, not a typical day, and may vary from classroom to classroom and from school to school. If you were to walk into a science classroom, you would see lots going on. As we discussed earlier, the science classroom is very busy, and students are actively involved at all times. Here are some of the things you might observe when entering a science classroom. Vocabulary word walls. You would see science words on the walls that students are currently learning or have learned recently. The science classroom places a huge emphasis on science vocabulary because it is a critical component of science understanding and comprehension. You would see students expected to use science vocabulary in their discussion with their teachers and their peers, as well as in their writing and assessments. Thus, the use of a word wall in science is important to help students with those expectations. Science tools. Science tools such as hand lenses, droppers, balances, etc. can be seen in the science classroom as tools for students to use when exploring new concepts and ideas in science. Science-based anchor charts. The students are constantly learning new things and making connections, so oftentimes teachers will use anchor charts to help students remember their learning and to have something to reference when making connections. Students work on the walls. Classrooms will also have evidence of student learning and highlights of student work up on the walls for everyone to see. Whole group discussions on the carpet. The primary science classroom is very interactive, where students work together to accomplish tasks, answer questions, explore, and discuss the science topics presented to them. Oftentimes, teachers will debrief with students on the carpet, where group discussions can take place and the students can work collaboratively in close proximity to each other. Long-term investigations. Students are constantly learning about how real scientists go about their work and how science often happens over a long period of time outside of the 60 minutes of instruction spent every day. So students explore science through long-term investigations, where they are able to observe science over time and collect data. Long-term investigations can be connected to what students are learning in their core instruction, but can also be based on topics that students are interested in exploring outside of their core instruction. Essential questions. Instruction in science is connected to an essential question, in which students should be able to answer by the end of the course of study, which could be at the end of that day's lesson, at the end of the unit, etc. These questions guide the lessons and are the focus for students and help teachers monitor student learning. Classroom discussions. The science classroom is not a quiet one. It is filled with rich discussions, questions, and scientific argument. Students often learn from their peers and are encouraged to do so by discussing questions posed by their teachers with their peers in the classroom. Student discussion is not only good for students, but great for teachers in terms of evaluation and monitoring student learning and possible misconceptions. Student notebooks. A critical component of the science classroom are science notebooks. Students use science notebooks to record their observations, draw and label to show understanding and learning, answer rigorous questions posed by their teachers, summarize their thoughts and learning, and gather data from investigations or experiments. Science notebooks are used daily and catalog the learning by students as they progress through the year. Engaging with science text. Students can often be found reading and engaging in science text in the classroom. Use of informational text in science is one way which students connect their hands-on exploring to the science behind it. For this slide, you will need the mygconnect.com login information that can be found in your packet. In the science classroom, there is a core resource text, National Geographic, that students have access to both physically in the classroom and online. The National Geographic textbook is a resource that teachers use to help students connect their learning from hands-on to vocabulary, science concept, real-world images, and examples of the science they are currently learning about. The text is also available online through the website mygconnect.com. On the website, students and families have access to the student textbook, an image library, vocabulary games, and much more. Please refer to your packet for the login information on ngconnect.com. There are many different ways that students are assessed in science. Students have multiple opportunities to show what they know and can therefore get enrichment or remediation based on how they perform on the assessments in science. There are daily observations, scenario-based probes, science notebooks, National Geographic chapter and unit tests, grade level science pre-assessments, and mid-year assessments. As you can see, there are many opportunities for students to show what they know. For this slide, you will need the NSTA article, Tips for Busy Caregivers. We learned earlier in the training that science is everywhere, so school isn't the only place that learning of science concepts take place. A child's home is a wonderful place to learn and experience the world around them. There are many ways in which caregivers can help students support the learning of science at home. Please turn in your packet to the NSTA article, Tips for Busy Caregivers. This article lists the different ways in which caregivers can support science at home. We will discuss a few of these tips from the article. See science everywhere. Caregivers can take opportunities to ask, what would happen if? Questions or present brain teasers to encourage children to be inquisitive and seek out answers. Children need to know that science isn't just a subject, but it's a way of understanding the world around us. We want to lead family discussions on science-related topics. Dinner time might be an ideal time for your family to have discussions about news stories that are science-based, like the International Space Station missions, severe weather conditions, or new medical breakthroughs. Over time, children will develop a better understanding of science and how it affects the many facets of our lives. Movies and TV shows with science-related storylines are also great topics for discussion. Do science together. Children, especially elementary-age children, learn better by investigating and experimenting. Simple investigations done together in the home can bolster what your child is learning in the classroom. Check with your child's teacher on what your child is currently learning in class and what activities you can explore at home. There are also many books on the market and numerous websites that present ideas for investigations. Connect science with a family vacation. Family vacations are a great way to explore science. It could be a hiking trip where you explore nature, or a discussion on tides during a beach vacation. Become active in your child's formal education by getting to know the teacher and the curriculum. Attending this caregiving presentation is one step in getting to know your child's education. We have just highlighted a few of the ways in which caregivers can support science at home from this NSTA article. Please feel free to read this article in more depth on your own for more information on ways you can further support science at home. For this slide, you will need the NSTA list of science trade books that is in your packet. Science and reading are closely connected in terms of supporting science comprehension and learning. To further support science at home, caregivers can promote reading science-based literature at home. Encourage your children to read books connected to science, whether fiction or nonfiction, can really help students learn and explore science. The National Science Teachers Association, NSTA, releases a list of trade books every year for caregivers and teachers that are science-based and engaging for kids. In your packet, please refer to the 2015 list from NSTA. These books can be purchased, borrowed from local libraries, or found on Myon, a resource that is available online for all students in Hillsborough County. For this slide, you will need your notebook, markers, crayons, or colored pencils. We learned earlier that vocabulary in science is one critical component that helps students comprehend and understand science concepts. We encourage our students to use science vocabulary when talking about the science they are learning and when writing about the science in their notebooks. In order to use a science word, one must truly understand its meaning. Practice and multiple exposures to the science word is key to true understanding of science vocabulary. One easy way for caregivers to support this is by practicing science vocabulary at home. Please open your science notebook to the next page and create the vocabulary organizer on the screen with the words listed in each part. Take a moment to discuss at your tables the one word that does not belong and describe why. Please also take turns explaining your thoughts. There are multiple answers to this question because it depends on your perspective. If you are looking at the parts of the plant, then maybe water does not belong, since it's not part of a plant. If you are looking at it from the perspective of which words are connected, then maybe the stem doesn't belong, because the roots absorb water from the soil. This is a model of how students practice with vocabulary in science. Students do not just learn the meaning of the word one time. They often interact with new words in science in many different ways, including vocabulary games and activities like this one. This type of activity can be easily done at home. You can create a vocabulary organizer with words your child is learning. Caregivers can ask for a list of words from teachers and ask their children about what words they are learning about in science, and do this same activity during dinner, after dinner, in the car, etc. For this slide, you will need Tracking the Rain data chart, the graph sheet, and the questions handout from your packet. Another way to support science at home is through data collection. Students are involved in data collection through long-term investigations at school on a regular basis. So doing this practice at home as well can support overall understanding. Here is an idea for a long-term investigation that can be done at home. One idea is tracking rain patterns over a span of time. All you need is a data chart, graph, and time to collect the data daily. In your packet is an example of a data chart and graph that you could use to collect the data for rainy days and non-rainy days. To collect the data, all you would have to do with your child is look at the weather for the day to see if it has rained or not. If it rained, then you put an X in the column under rain. If it didn't rain, then you would put X in the column under no rain. At the end of the specific amount of time, a month or two, you can count how many days it rained and how many days it didn't. Once you have the data, you can show it on a graph. After showing the data in both the chart and the graph, ask specific questions to help formulate a conclusion. Please refer to the question sheet in the packet for examples of questions you can ask your child when looking at the data. If you have any questions, please raise your hand. Once again, thank you for spending time with us today. For additional help, ideas, and information, please contact your student's teacher. For information regarding Hillsborough County Public Schools elementary science event and policies, please contact Shauna Tirado, the elementary science supervisor. You can email her at shauna.tirado@sdhc.k12.fl.us. We would like to thank you for your continued support of science. Have a great day.